Hello there, Mr. Sutton here with the IM323 Extra Practice #1 solutions on factoring basic trinomials. To factor this trinomial, we need to find factors of 6 that add up to 5, and they're both going to be positive because they multiply to give us a positive and add up to a positive. So let's see here, 1 and 6, that doesn't add up to 5, it adds up to 7. 2 and 3 adds up to 5. So we can write n plus 2, parentheses, n plus 3. For this one, we need factors of -9 that add up to 8 in order to factor this trinomial. So since the factors multiply to a negative, that means they have opposite signs. So let's see here. Things that multiply to 9 and basically subtract to 8. We've got 1 and 9 and 3 and 3. Those are our only choices. I'm thinking 1 and 9 is more promising. If we had -1 and +9, that would add up to 8. So we can write x minus 1 and x plus 9. For this one, factoring this trinomial, we need factors of 21 that add up to 13. So let's see here. Things that multiply to 21, we've got 1 and 21, adds up to 22, not 13. We've got 3 and 7, which add up to 10, not 13. And we've already passed 13. The next set of factors is 7 and 3, and we basically already did that. So that means this one is not factorable. There's no factors that work for this, so this one is prime. To factor this one, we need factors of -10 that add up to 9, and they have to have opposite signs because they multiply to give us this negative constant. So let's see here. We've got 1 and 10. Well, if we had -1 and +10, that would add up to +9. So we're going to write this one as x minus 1 and x plus 10. To factor this quadratic, we are going to need factors of -40, this constant here, that add up to this middle coefficient of -8. And they're going to have opposite signs since they got a negative when we multiplied. So let's see here. We've got 1 and 40, no way to get 8 out of that. 2 and 20, can't get 8 out of that. How about 4 and 10? Well, that would give us, let's see here, 6 if we subtract. It's still not going to work. How about 5 and 8? Well, there's no way to get an 8 out of that because 8 is one of the numbers and 0 is not the other number. And the next set of factors is 8 and 5, so we're basically starting over again. So it turns out there's no set of factors that we can get to multiply to -40 and add up to -8, so this one is prime. For this problem, to factor it, we need factors of -36 that add up to -5, and we know the factors will have opposite signs because we got a negative by multiplying them. So let's see here. Things that multiply to give us 36 and add up to -5 with one of the things being negative. Well, let's see here. We've got 1 and 36. No way to get a 5 out of that. 2 and 18. Still not going to get a 5 out of those numbers. 3 and 12. Well, that would give us a 9 if we subtracted. So closer, but still not what we need. 4 and 9. Well, this is interesting. If I had a +4 and a -9, that would add up to a -5. So I'm going to write this as x plus 4 and x minus 9. To factor this one, we need factors of 45 that add up to -14. And our factors both have the same sign because they multiply to give us a positive. And that means they're both going to be negative because they add up to give us a negative. So we've got 1 and 45, not going to give us 14 if we add those. 3 and 15 doesn't work either. How about 5 and 9? If I had -5 and -9, that adds up to -14. So then we can write x minus 5, x minus 9. To factor this problem, I need factors of -99 that add up to -2. And our factors have opposite signs because this 99 is negative when we multiply. So we've got 1 and 99. No way that's going to add up to 2. How about, let's see here, 3 and 33. Still not even close. 9 and 11. If we had +9 and -11, that adds up to -2. So we'll write k plus 9, k minus 11. For this factorization, we need factors of 21 that add up to -10. And our factors have the same sign because we multiply to get a positive. So let's see here. We've got 1 and 21, does not add up to 10. 3 and 7, if I had -3 and -7, that would add up to -10 and multiply to 21. So we can write then n minus 3 and n minus 7. To factor this thing, I need factors of 24 that add up to 11. And they're both going to be the same sign because we're multiplying to get a positive. So we have 1 and 24 adds up to 25. 2 and 12 adds up to 14. Let's see here. 3 and 8, that adds up to 11. So we have x plus 3 and x plus 8 for our factorization. To factor this trinomial, I need factors of 20 that add up to negative 9. Our factors have to have the same sign because we're multiplying to get a positive, and they're both negative since we add up to get a negative. So we've got 1 and 20 is not going to work. Adds up to 21, not 9. 2 and 10 adds up to 12. Let's see here. 4 and 5. Well, if I had negative 4 and negative 5, that adds up to negative 9. So then I'll write a minus 4, a minus 5. To factor this expression, I want factors of 48 that add up to 16. And they'll both be the same sign because this is a positive 48 that we're multiplying to. So we've got 1 and 48 is 49. 2 and 24, well, that adds up to 26. 3 and 16 adds up to 19, so that's a little bit closer. 4 and 12, that adds up to 16. So we're going to write then a plus 4 and a plus 12.